Welcome back. So in this video, we're going to look at solving a system of equations where the corresponding matrix is in row echelon form. So hopefully this will help you kind of see why row echelon form is nice. It's not quite as nice as reduced row echelon form, but it's a little bit nicer than just an arbitrary system of equations, okay? So I'm going to be looking at this problem. We're solving the system of equations corresponding to the augmented matrix that I have here, okay? So first thing I'm going to do is I'm going to translate this back to a system of equations, okay? So right now I have this matrix and it represents a system of equations, so I'm just going to translate it back to that system of equations. Maybe I'll use a different color for this so we don't get confused. So this one here, this first column corresponds to the first variable. We'll call it x. The second column corresponds to y. The third column goes with z, and then these last numbers out here are what we equal, right? So essentially I just do 1 times x, so x, 2 times y, negative 1 times z equals 1. Okay, so that's the first row of this matrix we wrote as an equation. Okay, our second equation is the second row. So I have 0 times x, which is just 0, 1 times y, so just y, okay? And then we've got 4 times z, so plus 4 times z is equal to negative 7, okay? And then you'll notice this last one here is 0x, 0y, so 0, and then 1z is equal to negative 2, okay? And now something I forgot to mention here is let's just check. I did say that this was in row echelon form, but let's make sure that it is before we go any further here. So the leading terms here are the first non-zero number here on this row is 1. The first non-zero term here is 1, and then 1, right? So it has the descending ones, and then so that's all good. Then it also has zeros below those leading terms, right? There isn't a 0 over here, but that's okay because there's not a row below it, okay? So this is in row echelon form, okay? And so when I converted it to a system of equations, what you'll notice here is this is a fairly nice system of equations. It tells you what z is just right off the bat, right? So we know what z is. We just need to find x and y, okay? Well, how can we do that? Well, this equation here just has y's and z's in it, right? And I know z, so I can plug that in. So in other words, what I'm going to be doing here is kind of like substitution, or really it's kind of like back substitution. We're plugging in what we found one variable to be to find the other variables. Okay, so I'm going to plug that z into this equation. Maybe I'll use a different color so we're going to plug in. Okay, and so when we do that, we get y plus 4 times z is negative 2 is equal to negative 7. And now we can solve for y really nicely. Okay, so we get y minus 8 is negative 7, and we just add 8 on both sides, so we get y is 1. Okay? So now I know z and I know y. So to find x, what I just have to do is back substitute these two into that first one, okay? So I just plug both of those in. So then we plug in, and we're also going to plug this guy in. Okay, so we're going to plug those both in to that first equation, and then we can solve for x. So when I do that, I get x plus, well, 2 times y. I found out y was 1, so just 2 times 1 minus z. Z was -2 is equal to 1. Okay, so I get x plus 2, and then minus a -2 is plus 2. So I get x plus 4 is 1, and then I just subtract 4 from both sides. Okay, so I get -3. So my final answer here is -3 was x, y was 1, and z was -2. So that's my solution. Okay, so you can kind of see how the row echelon form is pretty nice for solving these equations. You have to do a little bit less with reduced row echelon form, and so that's why we kind of prefer it as opposed to this, but this works pretty good too. So you can kind of start to see the versatility and power of these forms, so that you can kind of understand why we care about them, why they have special names. And what we're going to do next is I'm going to be given an arbitrary matrix. I'm going to try and get it into reduced row echelon form, and so that we can solve the system.